All right, we got the interval -1 to 1, and this is our function, and it turns out that f of x is discontinuous at -2, but -2 is not on the interval. So that's exactly what I'm going to say. So first condition is f of x is discontinuous at x equals -2. Okay, and actually I'm going to say it's only discontinuous. Only discontinuous at x equals -2. Therefore, it is continuous on the given interval. Okay, so that's condition 1. Our function is continuous. Now we need to check the endpoints. So, condition 2, f of -1 is -1 over 1, which is -1. F of +1 is 1 over 3. Well, f of -1 is less than 0. F of 1, which is 1/3, is greater than 0. So we have that. F of -1 is less than 0 is less than f of 1. So the conditions are met. IVT applies. Because the conditions are met. Okay, I'm trying to write this differently for all the problems, just to give you a couple examples of how you could write out the answer. So IVT applies because the conditions are met, which means f of x equals 0 somewhere, I'm running a room here, somewhere between -1 and 1. Okay, so here, let me do this. Let's get rid of this. We checked the conditions, they were all met. What just happened there? Can I get that? No? Okay. Let's do this. Let's erase all this junk. Boom, boom, boom. So we checked the conditions. They worked out. How nice is that? And IVT applies because the conditions are met. So f of x equals 0 somewhere on the interval. On -1 to 1. Okay, so that's the whole IVT part. Determine if IVT can be used. Yes. And if yes, explain why we did that. Find the 0. Okay, so we got to find out where does this thing equal 0. Well, a fraction only equals 0 if the numerator is 0, and that happens when x is 0. And 0 happens to be on this interval, okay? And that's what IVT says. It says there has to be some value where your function equals 0 between -1 and 1, and it turns out that it happens when x is 0.